son to rule
Alright, today we're going to talk about component forms of a vector. Let A, xy, be the initial point of a vector, and B, x2, y2, be the terminal point. The ordered pair that represent P1, P2 is x2 minus x1, y2 minus y1. Its magnitude is given by AB equals under the square root x2 minus I1 squared plus y2 minus y1 squared. To find the component form of AB, you would take 12, which is x2, minus 10, which is x1, and you would take 7, which is y2, minus 4, which is y1, and that would give you 2, 3. To find the magnitude of that, you would take 12 minus 10, which is x2 minus x1 squared, plus 7 minus 4, which is y2 minus y1 squared. And you would get the square root of 13, which is 3.61. Now we're going to do another example of component form. In this example, we have x2, which equals 12, and x1, which equals 16. You take that to find the first number, which is negative 4. Then you would take y2 minus y1, which is negative 8, minus negative 3, which will give you negative 5. To find the magnitude of that, you would take this squared plus negative 5 squared, which would equal the square root of 41, which is 6.4. To find the sum of a component form, you would take x1 plus x2 and y1 plus y2. In this equation, we're going to insert the w and times it by 2. So you take 2 times 6 and 2 times 8, which will give you 12 and 16, plus y, which is 10 and 4, which will give you 22 and 20. In our next example, it's going to get a little bit harder. And here, we're going to insert w and times it by 8. And then we're going to insert y and times it by 6. So 8 times 8 and then 8 times 2 will equal 64 and 16. And then 6 times 3 and 6 times 4 will equal 18 and 24. And then you add those together and you'll get 82 and 40. To get 82, you would add 64 and 18. And to get 40, you would add 16 and 24. Now, for some in-class examples with Molly Swartzmiller.